All right, welcome everyone. Going to give folks a few minutes to join and then I'll get started with our quick intro. So looks like got some folks joining already. So my name is Bo. I am with Acelab. I'm helping out hosting today's event with Western Window Systems. We've got Heather Bergeron here today who's going to be presenting the AIA course. I'm going to give just a few minutes of an introduction while folks are joining to let you know about a little bit about Acelab and what we do, as well as how you can find Western Windows and get in touch with them directly through Acelab's platform. And then after that quick little demo, we will get started with the AIA portion of today's course. All right. So today we're going to be learning about energy performance and proficiency with fenestration. And we're very excited to be bringing you today's course from Western Window Systems. So as I mentioned earlier, I'm with Acelab. Acelab provides free non-sponsored product research. This is a quick snapshot of some members of our team. So we're founded by architects for architects with the belief that we should be spending more time designing better buildings and less time trying to track down product data or get in touch with folks when we need more information. So here's a kind of example of some of those workflow issues that we were working to solve. So a lot of us came at this with, the experience of working in architecture ourselves. I was a former architectural designer and both of our founders are architects. So we really wanted to build tools that, we saw a need for in practice. That I'm going to jump over to our live site and just show you quickly how to find Western Window Systems. If you're interested in learning more about how you can use Acelab for your product research, I'll send over a link to a calendar invite in the chat later on so that you can sign up for a quick demo with me and learn more about how you can use Acelab to your benefit. So we've got a bunch of searchable product categories here. If you know exactly the manufacturer you're looking for, you can always just type it into the search bar at the top. So once you start typing in the name of the manufacturer, that'll start to auto-populate. We're going to head over to Western Window Systems page on Acelab. And from here, you can reach out to Western Window Systems directly just by clicking this contact button. So that's a super easy way to get in touch with Western Window Systems after today's webinar. If you've got any follow-up questions about the presentation, this is a great place to get in touch with them. Scrolling down, you're able to see an overview of information about their brand, check out videos, and then explore products right from this page. And you can also save products, organize them to your projects on Acelab. So it's a really great way to keep track of your product research, be able to keep everything in one place and keep it organized for future use. All right. I'll stop our demo there, but there's a ton more stuff to dig into here. So again, if you're interested in learning some more about Acelab, how to use it to reach out to manufacturers, how to use it to save products, feel free to sign up for a meeting with the link that I'll send over later. All right. That's the end of my quick intro. Just a few housekeeping items before we get started. So we did ask for AIA numbers upon registration. I will also send over a link to a form just in case you're worried you didn't submit your AIA number. You'll be able to submit it through that just to make sure we have it if you'd like to. Attendance will be reported directly to the AIA. Please allow some time for that to show up in your account. And if you have any questions about that, getting in touch with Western through the method that I showed earlier is a great way to ask about any questions that you might have related to that as well. And then last thing is I just want to encourage folks to please submit questions to the Q&A throughout today's presentation. We'll try to save some time towards the end to be able to answer some questions out loud. If your question doesn't get answered, we will have a record of all of those questions so that folks will be able to follow up with you after today's event and make sure all your questions are answered. All right, so with that, I'm very excited to introduce Heather, who's going to be presenting today's AIA-approved course. Heather, feel free to take it away whenever you're ready.
Let me know if you're able to see my screen, Bo.
Yes, we'll do.
Share screen, share. Can you see it?
Yep, I can see that. That's
Perfect.
great.
All right, ready?
All right, ready.
Good morning, everybody. My name is Heather Bergeron, and I'm the architectural consultant for the state of Texas for Western Window Systems, who is also a PGTI family of brands, which is our parent company out of Florida. And today our title is Energy Performance with Proficiency with Fenestration for the ICC. You can clearly see here, we have our provider information as well as our AIA course number, which will be provided to you on a certificate and our reporting of credit. You can see on this slide that we have all of our family of brands under the PGTI umbrella, our parent company out of Florida. So we have myself, which is Western Window Systems, who is out of Phoenix, Arizona. We have a couple more brands, Anlin Windows and Doors. We have Winddoor, of course, our PGT, as well as our Martin Door, which is our newly acquired company out of Salt Lake City for garage doors. So you will get one credit, our credit for health, safety, welfare. So upon completion of this program, all of your credits will be reported for all AIA members. Certificates of completion for non-AIA members are available upon request. We still typically send those out if you're not an Allied AIA member. And the objective here is to provide an understanding of the energy efficiency programs and the knowledge relating to the state energy codes and NFRC, which is the National Fenestration Rating Council, and green building programs. So on our agenda today, we are going to cover all the energy efficiency basics. The NFRC, again, as I mentioned, this is the National Fenestration Rating Council. Energystar, ways to improve the energy efficiencies with fenestration products, rebates and incentive programs, green building certification programs, and state energy codes. Also, the future of energy efficiency. So everything as far as energy efficiency and that is based on the international codes as the ICC. So the most recent version that I believe everybody's using this day and time is in 2018. Every 3 years, the ICC updates their codes. We should soon be receiving that new book for everybody to go off of the energy conservation code. Energy efficient basics. So the definition here is using a little energy as possible to get the same result as using a great deal of energy. This is accomplished by using a similar type of energy source that is capable of producing larger amounts of power energy, but at the lower energy use level possible in order to get the same job done. There's many different current ways to reduce energy. So a couple of different ways are renewable energy sources like solar and windmills. So we all know that windmills have been around for about 25 to 30 years. But having the different solar panels and different windmills out there across the US, other countries as well, this is a renewable energy source that we obviously are able to reduce our energy. That's with heating of water and domestic and street lighting. So I think we've all have seen recently within the last few years that some of the street lighting that we see in parking lots and around in neighborhoods and whatnot have the solar panels to reduce electrical energy as well. Water efficiency. So there's definitely many different irrigation systems out there to help also reduce energy by using water and irrigation. Lighting, as far as building fixtures, a lot of LED lighting has been around for many years now to where, we're able to conserve some energy as well. And of course, the envelope of performance in fenestration products as far as all of the walls of a home. This is where the envelope of the building is, and with, your fenestration products such as windows and doors as well. So the world's largest solar plant is shown here within the slide. It is located in the desert center of California. So there's about 550 megawatts that are near the national park that generates electricity to power of 160,000 homes here. So very, very large solar plant here in the California desert. And then here is an example on the slide of a windmill farm out in California that is supplying electricity to 45,000 homes based in the area of California. So as I mentioned before, we all know that the windmills have been around for about 25 to 30 years now. NFRC, the National Fenestrating Rating Council. So their mission statement develops and administers comparative energy and related rating programs that serve the public and satisfies the needs of its private sector partners by providing fair, accurate, and credible user-friendly information on fenestrated product performance. So not every manufacturer is basing everything off of the NFRC because it can be getting a little bit more expensive. So there are obviously default charts out there that a lot of manufacturers also use for fenestration projects as far as energy efficiency. So, but this is the mission statement that they base everything off of, and they give all the numbers. The fenestration product ratings here. So again, as I mentioned before, having the default chart here, but view factors of fenestration performance products as far as windows and doors and skylights shall be determined in accordance with the NFRC. So U factor shall be assigned a default U factor. You can reference this table and information. So within the U factors of the NFRC, they also provide you with that solar heat gain, which is SHGC, and visible transmittance, which is VT of glazed fenestration products for windows, glazed doors, and skylights. As I mentioned, this could be just a default number here from the NFRC. Here's an example of what an NFRC label typically provides on every single unit coming from a manufacturer. Most importantly, this is knowing what the U factor is knowing how well the product is actually insulated. Your solar heat gain coefficient, this is how much energy from sunlight is getting into the home. And our visible transmittance, this is how much light does the window allow through. Also, you have some other numbers here for air leakage and condensation resistance. Just some basic ratings too in regards to fenestration products. So we all know that there are different mini climates throughout the US. So there are some basic ratings if you're in a hotter climate or if you're in a colder climate. So basic ratings as far as U factor in a warmer climate would typically measure how well a product prevents heat from escaping a home or building. So that U factor rating generally falls between 0.20 and 1.2. So the lower the U factor, the better product is to keep that heat in. So the U factor is particularly important during the winter heating season. So think of a U factor being like golf. Golf, as far as being a sport, you know, the lower the number, the better the energy is going to be. We don't want higher numbers such as like football or baseball or anything like that. So always think of your U factor and solar heat gain coefficients being low and thinking of golf. Visible transmittance is your VT, is to measure how much light is passing through that glass. Typically VTs range from 0, being no light, to 1, which is all light. Your U factors also measure how well product prevents heat from escaping. As I mentioned, you know, there's obviously different seasons for the US. So, you know, you have our warmer climate where U factor is very less important, but a colder climate, a U factor can typically be very important to some of those customers. R value. So R values in windows are typically the glass, the spacer, and the type of frame. But then we also have U factors as well. And this particular slide is going to differentiate the difference between the two. So the FTC, which is the Federal Trade Commission, indicates that the U value is the representation of a single component. Okay, so a single component, whether that's the glass, the spacer, or the type of the frame. The U factor is the representation of the sum of all of many different R values, which is technically the total for one particular unit. So it's all of those items combined. So that's where the U factor comes into play. Windows are made up of different components with different R values. Therefore, the reason U factor is used to determine the overall performance measurements. As I mentioned before, your visible transmittance is the measures how much light is coming through a product. There's many different manufacturers out there that now have more glass. So, you know, your VTs, you know, want to make sure that we also have lower numbers as well on those. So all about the glass. So many counties and cities along Florida's coast have adopted different codes, one being the Sea Turtle Lighting Ordinance. So therefore, typically a 0.45 visible light transmittance value or less is required to comply. And there are glass partners and manufacturers out there that are able to provide you with the different types of glass that will be able to meet Florida's Turtle Code. Here's more information as far as basic ratings that are continued. So on this, we're talking about the differences in the number of heating days, which is your U factor, versus the higher number of cooling days, which is your solar heat gain coefficient. So depending on the type of day it is, as far as, you know, where that sun's at, as far as your daylight availability, to where, you know, at nighttime that you have no light coming through because it's so dark outside, you have all these different rays that are hitting the actual glazing itself here. So you can clearly see your radiant heat in this graph, your solar heat gain. You know, we want to make sure that we keep, you know, those UV rays from damaging any of the interior parts of the home or the value of the building. And then, of course, you know, we don't want to have any air filtration coming in through that unit either. Your solar heat gain coefficient is the number that's assigned to a window that tells you how much heat that the window lets pass into your home from the sun. Here again, your solar heat gain numbers range from 0 to 1, and the lower the number, the less heat will enter the home. Thus, in hot climates, a low solar heat gain is desirable, while in the cold climates, a higher solar heat gain is desirable here. Solar heat gain. So in colder climates, the higher the SGC number is better. In warmer climates, the lower the SGC number is better. So here again, we have the different climates throughout the US. And so the numbers there, as far as, you know, depending on what climate you are, we always want to think of what solar heat gain number we need to be at. Basic ratings and review. So here's an example of the building as a whole, as far as a home, or if you're working on a commercial project or whatever the case is. This is just showing you the different areas as far as U factors. That's measuring the heat from inside the room that can escape. So again, here we are, the lower the number, the lower the potential for wasted heat is being expensed. Your solar heat gain coefficient is measuring the amount of the outdoor heat that can enter the room. So the lower that number, the lower the potential for any wasted cooling expenses are for solar heat gain coefficients. Your air leakage measures how much air will enter the home through the product. So therefore, the lower the number, the lower the potential of the draft. We don't want any drafts coming through that product. And your VTs measure how much natural light can come into a room. A higher number means more natural light. Optional energy factors. So talking a little bit more about air leakage. So that's indicated by the ratings expressed as the equivalent cubic feet of air passing through a square foot of a window area. So if you take a actual size of a window you can actually figure out your square footage of that. So the standard requirement is a 0.3 CFM per square foot, okay? Your condensation resistance would measure the availability of a product to resist the formation of the condensation on the interior surface of that product. So a lot of these ratings are optional, and manufacturers can choose not to include it. That's whenever, again, that the default chart comes into play. So we just moved, we're about to move over as far as EnergyStar. So we've been on EnergyStar 6.0, but effective next week on the October 23rd of this year, we are now going to be at EnergyStar 7.0. So EnergyStar is a joint program of the U.S. Environmental Protection Agency and the U.S. Department of Energy that helps us save money and protect the environment through the energy products and practices. So energy efficiency is what we're talking about here. There are different areas as far as EnergyStar and their climate zones by state and the county or applicable zip codes. So being nationwide as far as EnergyStar, if you're going on a state level, here in Texas, we have 3. For EnergyStar, they base everything off of 4, but there are other manufacturers out there in other states that go up to 16, and I believe California is on 16. ICC goes off of 8, by the way. Here is a section of the EnergyStar tax credit for the energy efficiency in new homes. So this has been updated and extended through 2032. This is for homes and units that have been acquired on or after January 1st of 2023. So this basic level tax credit is specifically tied to meeting EnergyStar programs. So this is available to any new construction partners, as far as your homeowners that want to have the tax credit based on their new efficient home. Okay, and then here in the slide 2, there's just some information here as far as finding what program requirements and resources that EnergyStar has. And then, you know, obviously to earn your EnergyStar certifications, whether it's a new home or apartment, they obviously have to meet very strict requirements based on energy efficiency. So this is just a snippet from their website. EnergyStar elements, as I mentioned, you know, EnergyStar bases everything off of climate zones or zip codes, counties, states, whatever the case is. So for climate zone is typically what they go off of. They must have an NFRC rating to qualify to meet the recognition criteria for the residential windows and sliding glass doors. Here's a slide showing you based on the windows of those 4 different climates. So obviously, if you're in the northern part of the U.S., you can clearly see that there's different U factors and solar heat gain coefficients that you see there that will be based on your climate zone. And if you're in southern states, whether that is south central or the southern part, you can see where your solar heat gain coefficients and your U factors are based on that climate zone. Basing everything as far as EnergyStar based on your doors. So this is both swinging and your sliding. You can clearly see here too, basically where you're located as far as climate zones. You can see where your U factors will fall and your solar heat gain coefficients. So in the chart down there to the left-hand side, you have your opaque, which is like your frosted glass, your rain glass, different types of glazings, and that's just not clear glass. And then you also have your half-light examples there as far as, you know, what solar heat gain and U factors that you'll get there. EnergyStar comparisons. So again, 4 different climate zones, northern, north central, south central, and the southern, and then 2 different sides on those comparisons of windows and doors. So this is just a generic basic basis of what EnergyStar compares between windows and doors here and what climate zone you're in. Energy efficiency in windows and doors. So what makes a window energy efficient? Well, today manufacturers are using an array of advanced technologies to make EnergyStar qualified windows. That's whether that's improved frame materials, that's basics as far as your wood clad, wood composite, vinyl, fiberglass, aluminum. You have different multiple panes of glass, whether it's a two pane of glass, or if you have triple pane, or different other manufacturers out there that have other advanced technologies as far as glazing goes. And, you know, we all know that there's multiple glass manufacturers out there here in the US. There's different types of low E. Whether that's a hard coat or a soft coat. So that's, I covered that earlier as far as, you know, keeping heat inside for the winter and outside during the summer, right? So low E glass is very important. Your glass fills, whether that is your argon glass, there's obviously, which is typically what most manufacturers are using these days, but there's obviously other different types of glass fills out there. Then you have different edge spacers. So here on this slide, they're talking about warm edge spacers. So that spacer keeps a window glass pane in the correct distance apart. So here you can see that this is a double pane window here. So you have your inboard, outboard right here. Your breaking down of low E. So the first step here is selecting the appropriate coating. So your low E glazing falls into two broad categories. So as I mentioned on the previous slide, you have a soft coat and a hard coat. Both applications are involving depositing a thin transparent coating of silver or tin oxide on that glass surface. And there's a diagram here to the left-hand side. If you're looking for a soft coat glazing, so that's the most common type of low E. So that layer of silver is deposited onto the glass through a sputtering process after the glass has been manufactured. So the type of coating is fairly sensitive and needs to be protected inside that insulated glass unit to prevent any scratching. If you're looking into a hard coat glazing, during the manufacturing process of that, there's a pyrolytic or hard coat low E glazing that incorporates a thin layer of tin oxide into the glass while it's still hot. So that's applying it at a stage where it's welded into the glass, resulting in a very durable coating. Also, we have the low E placement. So in warmer climates, the best location for low E would be on surface 2. And there's an example here on the left-hand side that you can clearly see where that surface 2 is on the unit. In the cold climates, it's best on surface 3 for the maximum result. Okay, so that's going to be right there in that spacer area of where that gas is filled as well. So low E coatings in temperature and cooling dominated climates. So we typically get this question asked a lot. So this typically is, you know, working with any kind of homeowner or distributor or any of our distributors that have these questions that come up from their clients. So this interpretation is to help with that. So here's an example of a question. I've upgraded to a window with a low E coating to block the sun's heat and save energy. When I touch the glass from the inside of the house, it's very warm. Is the low E coating working as intended? So here's an example of an answer that you may be able to give to your homeowner or a distributor out in the industry. So all glass, coated or not, will absorb heat when it's exposed to solar energy. Low E coatings are designed to reflect non-visible wavelengths of light while allowing visible wavelengths to pass through the glass, providing natural daylight into the building. As the sun continues to shine on that insulated glass unit, heat will be absorbed, thus allowing the interior surface to become warm to the touch. In most applications, low E coatings can help the glass on the interior, which is about 10 to 15 degrees cooler than the uncoated clear glass unit, but they will not be cool to the touch in direct sunlight. So this is just the basics of some of the questions that can potentially come up from a homeowner or a distributor out there, basically on about low E coding. Here's an example of a thermal photo that is showing bright blue and green areas, indicating the cold air entering into the house. So you're noticing here how the windows are a major source of air leaks. So, you know, we don't want to have air leakage there. That's why it's very important in those opaque sections to have the thermal insulation that we need to keep from having air leaks, you know, escaping out. So here's an example from the U.S. Department of Energy that the average home of waste can be up to 40% of the energy used because of air leaks in a building envelope, which was what we don't want. Here's an example from the DOG Office of Energy Efficiency and Renewable Energy. So over the course of a year, as much energy is wasted through insufficient windows as traveling through the Alaskan pipeline. So here's an example of the Alaskan pipeline here. It's 800 miles long and 4 feet in diameter. There's 1 million barrels of crude oil that moves through this pipeline each day. So you know, there's a lot of energy going through this pipeline, so therefore we don't want any energy being wasted. So there are about 90 million homes here in the U.S. Most of these homes are can be up to or over 20 years old. So a lot of homes, a little bit older homes here, but about 90 billion square feet of glass is in that stock. So there are about 40 million windows that are sold every year, 3/4 of that being in a replacement / retrofit application, and then about 1/4 of that being in new construction. So what this means is product choices are critical in long-term efficiency and performance. And then the products that we choose and have choices from can keep homes from becoming obsolete too quickly. So a lot of folks are building homes these day and time or staying home within their homes this day and time. So, you know, being energy efficient and having the best possible windows that we possibly can here in the industry is being more efficient and renewable. Here's an example of improved energy efficiency options in an aluminum window. For an example, you have a typical single hung here and in a 24 by 48 size. So depending on the glass thickness that you have within that unit, you can clearly see what your solar heat gain coefficients, what your U factors would be, and your visible transmittance. You also have the choices of having different tinting on the glass. So whether that's a gray or a bronze or a solar band 60, there's different choices that you have here to be energy efficient. Here's an example for a vinyl window, for a typical single hung, again in a 24 by 48 size. Depending on your glass thickness and your insulated unit here, as well as your clear glass, gives you your different solar heat gain coefficients, your U factors and your VTs. And then it's also showing you here on the right hand side, if you go with 3/16 of an inch on a insulated unit here, it'll show you your tax credit that you will have based on your climate zone and EnergyStar. Here's just a case study that one of our distributors completed a few years ago. This is just showing you a comparison of what size air conditioner is sized with your window options. So this particular distributor took 3 identical homes here out of Houston, Texas, but the results were very, very different. So if you have a solar pane home with bronze tints, and that solar heat gain coefficient, you have a very, very high number here of a 0.62. We all know that in Houston, it's very, very humid and very hot. So we want to think of those numbers. So here, that particular home, as far as the size of an air conditioner, was 4 tons for the HVAC. If you use or choose a double pane window and door option here, your lower solar heat gain and your low E will be about 0.34 on your solar heat gain coefficient C. So being more energy efficient, maximizing that glass, you have about 2.5 tons of UHVC that's being used. This information has been provided on the courtesy of Cardinal Glass Corporation. Rebates and incentive programs. Database of state incentives for renewable and efficiency. So here is a link to Desire. That's DSIRE. Please make sure you spell it right whenever you're going on the web to look up their information and what all information they can provide to you. So this is a comprehensive source of information on a state, local, utility, and federal incentive and policy that promotes renewable energy and energy efficiencies. The Desire was established in 1995. It is an ongoing project of the NC Solar Center and the Interstate Renewable Energy Council, funded by the U.S. Department of Energy. You can reference their link below. Within their link, when you go to the actual web page, here's where you can find different policies and incentives. You can obviously type in whatever zip code you're located here to pull up the information. You can become a sponsor. You can also donate. But you can clearly see here that they're just showing you what all kind of incentives are based on your zip code, what state you're in, and your energy. Here's some more information for rebates and incentive programs. So Efficient Windows and collaborative EWC members have made a commitment to manufacturers and promote energy efficient windows. This site provides unbiased information on the benefits of energy efficient windows, describing on how they work and recommendations for their selection and use. Here's a link to efficientwindows.org that you can learn more from on how to be more energy efficient. Windows for every season. We're going to go through just some benefits on energy and cost savings here. So here's green building certification programs, which you can, you can have these types of incentives by being LEED, by being green. LEED is the leadership in energy and environmental design. Depending what type of building you're involved in on your upcoming projects, there's different certifications that LEED has as far as how they look at having that building be LEED. You have the green seal, which gives you just a green seal. You have up to a LEED gold, which gives you the gold seal, or a silver, which is the blue, or a platinum. So depending on what level of green building you want to be at and what products of you're choosing to be LEED and be green, depending on what those manufacturers product information as far as your specifications and becoming green or LEED will depend on what seal that project will be noted for. The National Association of Home Builders, they also have different green building programs, different tiers being bronze, silver, gold, or emerald. You can also pull up this information on their website there, cited below in the right-hand corner. You have your Florida Green Building Coalition, so standing for FGBC. You have the IGCC. Here we are with the American Institute of Architects, the AIA, announced its support for the International Green construction code. So this is a new model, a code that is expected to help conserve energy both in commercial buildings and residential structures while providing direction for safe and sustainable building design and construction. And here's some information as far as your energy code chapter. So this is just showing you a comparison and how a building is considered residential or commercial. So residential buildings with 3 stories or less may fall into the residential energy code. If you're typically above 3 stories, it may fall into the commercial energy code. So sometimes there are some residential buildings that have maybe 4 stories. If you have a terrace or something like that, that they're considering a 4-story on that top level. But it's all based on the area you're in and what energy code you're going to fall within. The 2 standard compliance path within the code. So some manufacturers base some of the information off of their different paths that they're looking at. Maybe you choose the performance path, and that's typically the long form. And it kind of the same thing as a tax form of your 1040 being a long form, right? So this is a way to comply. So today that represents plus or minus about 98% of new energy permits. So that's mostly used for new construction. Or maybe you're taking the prescriptive path, which is the easy 1040 way of complying. And this is mostly used for retrofit applications. So the prescriptive energy value will force that IG or low E in most applications. Performance paths for compliance. So designers need to use an energy compliance software tool approved by the Florida Building Commission. This analysis only includes heating and cooling and service water heating. So the use of this software allows design professionals to perform a trade-off between U values and solar heat gain ratings. So when using these trade-offs from this particular section R4 or 5, the area is weighted in an average maximum allowed for the fenestration solar heat gain coefficient in your climate zones 1 through 3. The prescriptive path for compliance. So with this, it's predetermined path that designers must ensure that the proposed windows and doors have a U value and solar heat gain that meet or exceed the required ratings for their area. In this section, the code specifically specifies that windows and doors must bear the label with the energy ratings that are independently confirmed by the NFRC. Products lacking such a label shall be reassigned a default chart for the solar heat gain coefficient or U factor from the specific table that you can see here in the slide. The code specifies that when the U factor varies between the fenestration products, the use of the area weighted averaging is allowed to satisfy the U factor requirements. Here's an example of a 2022 building energy efficient standard based on your climate zone. Typically, we're 1 through 4, depending on if it's state or county. But this has up to 16, as I mentioned. For example, California has 16 zones because it's based on, I think it was city there. I have a chart here that I'll show you here in a minute. But you can clearly see here, based on fenestrations and doors, where your climate zone would be and where you would fall within that climate zone. So if you're in a maximum U factor rating, it looks to be from a 1 through a 16, you're at a 0.30 maximum U factor here. Here's an example of your solar heat gain default table, coefficient default table here. Based on the type of frame, material, and glazing that you have chosen for your project with your homeowners or building owners. So here, if you choose a metal type frame with, say, for instance, clear and a fixed different type of product, like a window wall or just a fixed unit here. You can see that in a double pane solar heat gain coefficient, you can be around a 0.73, depending on the type of different products that you're choosing here. Here's an example of your U factor default table. Depending on your type of frame again and your product type. And so say, for example, if you're in a metal frame with a skylight and you're wanting to look of the differences between a single pane and a double pane, this is the default table that you would see of the differences between the two on U factor. California climate zones has a diversity of climates that are not seen in any other state. That statewide provisions adopted into the California Energy Code accounts for these variations using a set of 16 climate zones. So several efficiency standards such as these, as far as the envelope and fenestration of the window and door materials, depend on the specific climate zones that building is located here. So very important for you guys to know, as far as architects, contractors, and building officials, to know what climate zones apply for your project. So here's an example of the IECC climate zone map. So 4 climate zones here that you can see. As I mentioned before, you have the northern, you have the southeastern, you have the southern. So there's the examples there as far as where you're going to fall on that climate zone. Here's an example of the 16 different California climate zones. So it's assigned by the zip code. And here is the website that you can pull up to see exactly what climate zone that project would be for you if you're out in California, or if you have a client that is building out in California and you're in another area of the US. Here's an example of the Florida Energy Climate Zone. So Florida is broken up into 2 specific climate zones, both with different code requirements and product needs. So if you're in the southern tip, like towards like Miami, you would be in a climate zone 1. If you're up in the Panhandle, say for instance, in Destin, Florida, or anything like that, or if you're visiting Disney in Orlando, you would be a climate zone 2. For locations in climate zone 1 with a cooling design pressure of 95 degrees Fahrenheit or greater, this is the section that you would see for the maximum U factors for vertical fenestration. So this is just clearly just giving you that labeled and certified by the manufacturer as far as, you know, what is the exception of climate zone 1. So there's obviously a max here that are allowed for the different U factors for vertical fenestration for all air-conditioned spaces. So, for example, if you're in a fixed metal framing area, you're going to get a U 0.50. If you have an entrance door metal framing, you're going to be in a U 0.83 as for an example. So this is that exception of climate zone 1. The future of the energy code. So we're looking ahead. So what is the long-term goal here? So there's been many talks in our government that eventually that there's going to be 0 energy homes here. So as of June of 2018, the U.S. Conference of Mayors resolved in continuously strengthening the country's model building code, energy code. So with the IECC, it's putting in all the guided paths to be net 0 of energy building and construction by 2050. But we know that there are several states out there that have increased the date now to be 2035. And here are a list of our references of some of the information that we have shared from you today. So Digital Codes is a public website for your state building codes. Quick location in choosing from your state. And here under PGT, We have other courses that are available to you for your continuing education. So you're more than welcome to reach out to us anytime. Whether, you know, from Acelab when I'm working with Bo and Acelab, or if you would like to ever come out on one of our architectural events that we have, we do provide you different courses within that training. And this will conclude our CEU today, energy efficiencies and fenestration performances. If anybody has any questions, feel free to put that up on the screen so that Bo can relay that back to us. And then myself or my colleague, Jim Heiss, will be able to answer those questions that you guys may have from the information that you received today.
Awesome. Thank you so much, Heather. That was super informative and really well done. So we have a few questions already in the chat. And as Heather mentioned, feel free to submit any more questions in the Q&A. We've got some time to get to some of these today, and we will have a record of any questions that we don't get to. So I'll just start off at the top and start reading some. You and Jim can chime in if that sounds good. All right, so first from Addison, we have, does a higher VT value mean a higher SHGC value of the same assembly?
Heather, do you want to answer that, or do you want me to?
I'll let you go ahead and answer that, Jim. Thank you.
Okay, the answer is that they're basically related, but it doesn't necessarily mean that. The visible transmittance is going to be how much light actually is allowed to come through the glass. Solar heat gain coefficient can be controlled with the low E. So you can still have a low E and still allow light to come through. The low E is basically going to deflect a certain percentage of the amount of ultraviolet rays of the sun and sort of bounce them back. I mean, it's extremely effective. There's actually been some cases where the solar heat gain was so low that the sun was actually reflecting off of a customer's window and melting the vinyl siding on a neighbor's house. But that had to be it was a perfect storm situation. It's not a common thing you're going to run into. But again, it's they do have a correlation with each other, but no, one doesn't actually alter the other one. It's going to depend on how that solar heat gain coefficient is being handled. In other words, whether it's going to be a double low E application or triple applications. There's different ways to do it, as well as different whether you put it on the what surface of the glass you put on, surface number 2 or surface number 3. So there's too many variables to make them tie in close together. Does that answer the question?
Yeah, I think it answered it for me. Addison, if you have any follow-up questions to that, feel free to enter that into the Q&A, and we'll try to get to that too. All right, the next one, what pressure is used to measure a max infiltration rate of 0.3 CFM per square feet?
I do not have the answer to that one. I'd actually have to look that up. We can actually look that up and get back with you on it if you want, but I don't have that exact number. I have too many numbers floating through my head right now, and I don't want to quote you the wrong one. So whoever asked that, if you want to reach out to Heather, we'll get that answer and send it to you.
Awesome, great. We'll have a record of that. So yeah, we can follow up about that one. All right, next up, at a quick glance, the 4 climate zones looked different between the windows and the doors. Is that the case, or am I incorrect? If so, is there a reason for that?
I've never seen the difference between them. I think they should be. I'd have to go back and look at the maps at a glance. It might have been because of how one map might have been magnified more than the other in size wise, but they should be the same climate zones. Those climate zones shouldn't vary between the windows and the doors.
The doors were just the doors were just based off of swinging and sliding, so that could be somewhat too, depending on the half.
Yeah, I'd actually have to look at the 2 maps side by side to see if they're exactly the same or not. Those maps actually were pulled off of the website for Energy Star. So I didn't create the map, so I don't have that exact answer. I'd have to look at them ideally to see if they're exactly the same or not, and overlap them.
Okay.
Cool. All right, the next one, so somebody asked if it would be possible to get a listing of all the web links and professional resources, which I know, Heather, you already provided on a screen.
Yes.
Maybe if you would want to pull that up for a second, just to make sure whoever asked, if you want to grab a screenshot or just note those down, that would be great. But yeah, really awesome resources shared in today's presentation. All right, let's see. Addison has a follow-up question. First, thanks, Jim. Quick follow-up would be, can you reduce the UV light transmittance with a lower VT value? I assume there are multiple films to apply to the glazing.
Yeah, I'd be very, very cautious in that. The reason I say that, when you putting what a lot of people don't realize, when you take an insulated window and you put a film on it that's put on the inside of the home. Well, what happens in many cases is that you want to check your manufacturer if you do that, because in most manufacturers now you're going to void the warranty. And the reason for that is it's put that film that you're putting on is on the interior of the house. You can't put it on the outside because it'll get damaged. So you put it on the inside, and then when the sun shines from the outside, it goes through and it's actually hitting that, warming up the temperature, or the gas, or whether it's air or gas, argon gas, it's heating that temperature up in between. It can cause stress cracks. So when we talk as a manufacturer, when we talk about tints, we don't talk about aftermarket tints like that. That's where we talk about different tints that are available to control the amount of light that comes through. But that tint is actually put in throughout the glass itself. It's not an aftermarket item. So the tint would be that piece of glass would be solid tint. Does that answer the question?
Yes, I believe so. But again, Addison, if you have follow-up questions, feel free to submit those. All right, looks like we've got time for one more. So Tom asks, how do I get people off of vinyl windows and air leakage, question mark.
I'm not quite sure what he's actually asking. How do you get people off? In other words, switch from vinyl windows? Is that the question? To pay perhaps aluminum windows, like a thermal broken aluminum?
I think that might be,
There's
yeah.
Yeah, I think I'm assuming that's probably what he's talking about. The reason being is, if I saw a study once where about 60% or 60+% of all the windows in the United States that are being replaced today basically are being replaced with vinyl windows. And that's because of vinyl is a product that doesn't use molecule to molecule transfer of heat. And so they're more energy efficient. However, aluminum uses molecule to molecule transfer of heat. And that's why Western, for example, uses what's called a thermal broken aluminum. That prevents that aluminum for basically the heat from transferring through to the inside. And so it becomes just as energy efficient, if not better than basically vinyl at that particular point. So I'm not sure if I think that's what that person was getting at. Most people have vinyl windows and they're familiar with it. So when they do a retrofit, they may ask for vinyl windows simply because they want something they're familiar with, not something they're not familiar with. But thermal broken aluminum is a much stronger product, basically, than what they'll get with a vinyl product.
Awesome. All right, we've got 2 minutes, so let's get to maybe one more. So real quick, I see someone had asked if they could get a copy of all the slides. Heather, is that something you can provide?
Yes, I can provide that in PDF.
Okay, awesome. So yeah, Roger, we have a record of that you asked. So
And whoever asked about the differences in the websites too, I can definitely send out an email as well with all that information too. So
cool. Great. All right. Let's see, one more real quick, and then we'll let everyone go for today. So does a low E coating work in temperature zones? And if so, what surface would it go on?
The answer very quickly is yes, it does work in all different zones. What surface we put it on will depend on where the product is going. If it's in the south, generally it's going to be on the surface number 2. That's counting from the outside, always count from the exterior. If it's up north, then they'll put it on surface number 3 because it will help more with the U factor. Where on surface number 2, down south, it works better, excuse me, at surface number 2 for the solar heat gain. And we want to prevent that heat from coming through the glass.
Got it.
You don't have to specify as an architect where to put it on. You just have to provide the manufacturer with the energy numbers that you want, and they'll determine where it belongs to be able to do that.
Great. Awesome. All right. Well, I think with that, we are at time. So I just want to thank everyone again today for coming out for today's webinar. And thank you so much for all of the really great questions. We really appreciate all the engagement. And thank you, Heather and Jim, for presenting today's information. It's been great. And I hope everyone has a lovely rest of their Tuesday.
Thank you. Bye, guys.
Hey.
Bye, everyone.